This is a preview of Aurora, a new way of thinking about programming. Let's see how it works. With Aurora, we took a simplifying view of what programming is. It is only data and transformation. And data has a number of very nice properties to it. One is that you don't need very much of it to represent many different things. A simple vector and some strings, and we have a to-do list. A vector with strings and nested maps and even other nested vectors allows us to model HTML. I can add a class to this h1 tag that has a class of greeting and then set its content to hello world. Now I've represented some HTML. I can even represent myself. I have a name, it's Chris. I have a height and it's short. We need very few kinds of data to represent the vast majority of the world, which is a very nice property because it means we need to learn about very few things. Another great thing about data is that it is fact. Data does not change. All you can ever do is create new data. So if we have a counter with a value of 1 and we wanted to change that to 2, we could sit here, we could click on it and change it to 2. But that simply created a new map. Our original map is unchanged. This means that in order for us to observe what our programs do, we simply need to capture the inputs and the outputs. Another wonderful thing about data is that the operations are very simple. This means that I can do them directly and visualize them in the environment. It's the environment's job to then just capture the steps that I'm doing. So we have data and we have the ability to perform some operations on it, so let's see what we can do with that. We'll create a vector here and we'll put some numbers in it. We'll go up to 4, I guess. And on the right hand side we can see the result of that step. We get a vector of 1, 2, 3, and 4. I mentioned before data is very simple, and so there really aren't very many operations we need to be able to do. In this case, we'll transform each element by doing stuff, and you can see that just returns nil. So let's go and do stuff and change it here. We don't want to just return nil. We want to do some math. We want to take each one of those numbers and we want to add 1 to it. Now if we go back, we'll see that we now have a vector of 2, 3, 4, and 5. But let's make this a little bit more interesting. Let's rename do stuff. We're going to call this add counter. We have this counter map. Let's pass it into our add counter steps. And now we have that available to us. And we can replace our 1 with our counter. And now anytime I change the counter, everything updates. And now we're adding that counter to it. But let's take this another step further. Let's create a little bit of UI that allows us to increment that counter. And I showed you before that we could represent HTML as a vector of vectors. And what we want is we want a button, and it's going to have some properties, some attributes. We want a click attribute, right? And we're going to set it to a new set of steps. And we'll call this increment. Now this doesn't give us anything right now. All we have is some data that represents HTML. We need to use something called a transformer to turn it into HTML. Transformers are our escape hatch, a way of doing the scary side effectful things that we need to do, like drawing to the screen. But if we look inside of our do stuff steps, right, it's not doing anything yet. So we want to add our counter in scope. And if we click increment again, it's not like anything's going to happen because we haven't set out our steps. So instead of returning nil, what we want to do is we want to do some math. We want to add 1 to our counter. Now, doing this isn't enough by itself, right? We're just manipulating data. We haven't actually changed anything because data doesn't change. We need to just create a new version of this counter. So we need to change the value of this key to be the result of our little math expression. So we drag that in there. And this won't by itself do anything, right? All we've done is created a new map that has a counter with the value 6. The last step is to use a transformer to say run this program again with this new value of this map. And you can see as I'm hitting increment, the value is going up. And if we go back to root, we'll see that that's true here as well. And every time we click on it, everything in the environment is updating. Everything in Aurora is live. And so if we go and we modify our little bit of HTML here and we'll add a span, we'll see that over on the right hand side our span is created and it's there, and if we drag our increment or our counter's value in it, we see it all just updates exactly as you would expect. So we have the basics. Let's look at something a little bit more interesting. I figured we'd take a look at a little data science example. So I have some data out of Mongo, and this is usage data from a website. And we can see we have time and date. So that's the amount of time a single person spent on some date on our website. And so what we want to do is get a graph of the average amount of time people spent on our website for each of these days. The first step is to get these in groups by date. So we'll group them by the value of date. And now we have a map, and the keys are the dates and the values are the lists. And we really only care about the values. We don't care about the day itself. So we'll get those values. And what this gives us is a vector of vectors. Each of these are the groups of date. And we want to go over each of these now and get the average amount of time spent. So we'll transform each of these with do stuff. We'll change that to get average. And we'll click on it. And so here's one of our groupings. And we'll drag this down. And what we need to do is extract the time out of each of these. So we'll extract the value of time. And that gives us a vector of all of the times. Now we need to do some math. When we do math in this environment, though, we don't write code. We don't describe the set of steps we need to take to do the math. We just write the math out in math. And so in our case, we want to do average. And we know that average is the sum of all x's divided by the count of them. And so we see the actual mathematical notation, we see the equation that represents the mean. And we have our average. So let's go down here and see that what our result is, right? We now have a vector of all the averages. And the last step we wanted to do was draw a chart. And just like with math, we're not going to describe how to draw a chart. We're just going to drag data on one. And then we can fiddle around with it and see which way is the best way to sort of visualize this for ourselves right now. So there we go. We went from data to cleaning it up to doing some math and then drawing a chart. And the entire way we did it by directly manipulating that data, by directly manipulating and describing exactly what we wanted. And it only took us a couple minutes. And it turns out that if you don't explain all of this stuff, it only takes about 40 seconds. Hard to beat that. So we've seen a world that obviously fits very nicely into something about data and transformation, right? We've only shown sort of data-centric examples. Let's look at something that is a lot more stateful, something where this sort of functional way of thinking about the world doesn't tend to do very well. And the example I thought we would look at is to do MVC, which is kind of like the minimum viable complete client-side project, right? It's a to-do list that adds all sorts of little interesting functionality. And you can see as I was typing in new to-dos, the data in our environment is updating, right? There's no difference between the data in our environment and the data in the actual running program. Everything is live from the ground up. And so as I'm manipulating the program, we get to see exactly the effects of that. So let's dig in and see how this works. We'll look at this remove completed button. So as I click these on and off, you'll see that the values are changing. And we can see the steps that draw that little button in the right-hand corner. It says, well, of all our to-dos, match the ones where done is true, and get the count of those, and then find a match for the count. If it's 0, show nothing. Otherwise, we have things that we want to show the button for, so we'll show the button. And when we click on it, we see the steps that it's going to perform. It says, of these, match where done is false, and then replace the original set of to-dos with the ones where they're not done yet. So let's go back and let's look at the thing that actually draws a to-do, right? It says find a match for our current to-do, and if the editing is true, then we show an input. Otherwise, we show what we see there. And so if I double click on this, editing is now true, and we get an input. And I can modify this to-do here. I can say, well, we'll say get more milk, and it did the right thing. And now editing is false. And let's see what happens when we click on our check mark, right? This toggle done set of steps. We can see, well, we find a match for our current to-do. If done is true, then the new value is false, otherwise it's true. And then we just associate done with that new value and replace it. That's it. So let's go back and let's look at something else. Let's see, this remaining to-dos text. And as I click these on and off, right, we see that changing. And we can see how this works. It says, well, match the ones we're done as false and get the count of them, and match against that count and create a little string. That's it. So there you go, a program that is very state heavy, but it's built the exact same way we were building things before, by directly manipulating data structures and just capturing the steps. This means that the programs are always observable, that we are always being direct, and there's no incidental complexity here. We weren't forced to figure out how things update or any of that. It just automatically happened for us. This is a dramatically simpler form of programming, one that because of direct manipulation can apply to a lot more people. Aurora is a better foundation for programming, but ultimately it's a new medium for thought. Imagine what problems we could solve if we were finally free to focus on them. And by we, I don't just mean programmers. I mean everyone. That is what we're out to achieve with Aurora.